We are in the very last unit, Unit 8, Electricity and Magnetism. Let's go ahead and get started with Lesson 1, Electrical Charge. The Hoover Dam in Nevada, an engineering marvel, is one of the largest projects ever built by humans. At the foot of the dam, a huge power plant provides electricity to much of the western United States. To understand how the power plant works, you need to know about two forces, electricity and magnetism. You will learn about these forces in this unit. Have you ever seen a flash of lightning or counted the seconds waiting for thunder? Lightning occurs when electrical energy is transferred from the sky to the ground. Something similar happens when you walk across the carpet and then feel a small shock as you touch the TV. Electric charges, which can be found in all materials, cause both lightning and static electricity. Let's take a look at electric charges, what they are, and how you can observe their effects. If you have long hair, you may have combed it and then watched it stick out in all directions. At the same time, your comb may have acted strangely, attracting small pieces of paper to it. These responses occur because electric charges that build up as the comb runs through your hair. Take a look at these images in the gallery. Each one shows an example of static electricity. Then read on to find out how these phenomena happen. Static electric charges come from specific parts of an atom. Every atom has a nucleus containing positively charged protons. This nucleus is surrounded by negatively charged electrons. A positive charge is represented by a plus sign, and a negative charge is represented by a minus sign. Electric charges always act in a certain way. Opposite charges attract each other, and like charges repel each other. If a positively charged object is near a negatively charged object, they will pull closer together. If two positively charged objects are near each other, they will push each other away apart. What do you think happens when two negatively charged objects are near each other? Well, let's look. Here we have negative, positive, positive, positive. The negative and the negative would also not attract each other. The term force of attraction describes the force that pulls opposite electric charges together. It is also the force that keeps negatively charged electrons around a positively charged nucleus of an atom. Atomic particles have electric charges. Electrons are particles with a negative charge. Protons have a positive charge. Just as you add numbers in math, you can add charges. Negative charges cancel out positive ones. If you have equal numbers of each charge, the combination is neutral. It has no charge. Therefore, atoms with the same number of protons and electrons are electrically neutral. They have no charge. An atom that has unequal numbers of protons and electrons is a charged particle called an ion. The charge of an ion is equal to the number of protons in the nucleus minus the number of electrons. If the ion has more protons than electrons, it has a positive charge. If it has more electrons than it has protons, then it is negatively charged. You can see what happens to the charge when a sodium atom loses an electron. You can look right here at these numbers and see how it's changing. Everyday objects can also have electric charges. This occurs when atoms of the object gain or lose electrons. When a balloon is rubbed with a piece of wool cloth, electrons move from the atoms in the cloth to the atoms in the balloon. This causes the balloon to have a net negative charge because it has more electrons than protons. The wall is neutral. As the balloon gets closer, its negative charge repels electrons on the nearby part of the wall. By pushing electrons in the wall a little farther away and pulling the protons a little closer, the balloon sticks to the wall. The force of attraction between the opposite charges keeps the balloon on the wall. If you rub two balloons together with a wool cloth and held them close together, what do you think would happen? The answer to that would be that they would repel one another because they would both have a negative charge. A particle that has an electric charge affects the space around it. The electric influence around a charge is called its electric field. Please make sure you write this definition in your science journal. The effect of a particle's electric field on other objects depends on the object's distance from the charge. The field is stronger at a point close to the charge than it is at a point far away, so the effect of the two charges on one another decreases as the charges move farther apart. Force between two charges depends on the amount of charge and the distance between them. The amount of charge is shown by the number of plus signs. If the amount of charge increases, the force of attraction and repulsion between them increases. If the distance between the charges increases, the force between the charges decreases. This applies to both attraction and repulsion. Think about the two balloons that are electrically charged. To get two charged balloons to repel each other, they need to be near each other. Why won't they repel each other if they're far apart? We just discussed that. They won't repel each other because the electric field each charged balloon produces will decrease with greater distance. Let's take another look at examples we saw earlier of static electricity. Why are the objects attracted to or repelled to one another? When you comb your hair with a plastic comb, electrons are transferred from your hair to the comb, leaving your hair with a positive charge. Each charged strand of your hair is repelled by the other strands, so they move apart. The girl in the picture has her hands on a very strong, an even stronger source of a static electricity. It's called the Van der Graaf generator. Her hair stands straight out. Look at the two middle pictures. If tissue paper and styrofoam pieces are neutral, why are they sticking to the comb and the balloon? That's because the tissue paper is neutral. However, as the negatively charged comb gets close to the tissue paper, electrons are repelled in the tissue paper, and protons are left behind. This causes electrical attraction between the two objects. The same thing happens with the balloon and the pieces of foam. Here's a sticky question. Why do clothes stick together in the dryer? It's because clothes dryers, different types of clothes are rubbing together. Some, such as cotton, tend to lose electrons easily, while others, including polyester, gain electrons. The opposite charges on these different materials cause them to stick together in the dryer. An electroscope is an instrument for detecting static electricity. One type of electroscope, shown here, consists of two thin metal leaves suspended from a metal hook. When an object with a positive charge gets close to the hook, electrons flow from the hook from the leaves. When an object has a negative charge, the electrons of the hook flow down the leaves. In either case, the leaves have the same charge, so they repel each other. There is a super easy, fun experiment that you can do in this lesson and make your own one. If you came to our Class Connect for Unit 8, Lesson 1, you would have seen the one that I made. It only takes a few minutes, and you probably have everything you need in your home. So why don't you check it out after watching the recording? In a static electricity system, electric charges build up but do not move. When the electric charges move or are discharged, an electric current is created. Have you ever felt a shock after you walked across the rug or touched the doorknob? That is an example of an electrical current. As you move your feet across the carpet, static electricity is transferred to your body. And when you touch the doorknob, you are transferring that electrical charge in an electrical current. Lightning works in a similar way. Static electric charges build up in the clouds and on the ground. Eventually, the negative charge of a cloud moves from the sky to a positively charged ground, and vice versa. When this happens, you can see a flash of bright white. You will learn more about electrical currents in lessons to come. So here is that experiment I was telling you about. You can go to your lesson and click right here, and these are the only things you need. You don't even need the balloon to have a great time with this experiment. That's totally optional, but would be so much fun for you. Please go ahead and click on the lesson review and answer the questions to make sure that you are ready to take your assessment for the end of this lesson. Once you have, you can mark it complete. See you in Unit 8, Lesson 2.